This is really important. When I was thinking how I'm going to replicate this at a large scale, how I'm going to replicate this at a large scale, and I realized that in the biogas pipelines there was a condensate. In every single anaerobic digestion plant, in the pipelines, there is a condensate. Ladies and gentlemen, please be aware that the water scrubbing is the technology most widely used for upgrading of the biogas to biomethane. Water scrubbing. So let me show you. This is the schematic of the manure digestate plant. So this is the biodigester under mesophilic condition at 40 degrees. This biodigester is fed with dairy, slurry, manure, and whey from cheese making, and other stuff. At the very top, we have a biogas pipeline coming out. In that pipeline, there is condensation. And we have 2 points of sample that I am showing you here. In every single anaerobic digestion plant, this is happening. And we can harvest the condensation at this point. I'm showing you this as a sample, but I actually harvest that condensate, biogas pipeline condensate, in food waste digestate plant, in the manure digestate plant that I just showed you, and in other waste digestate plant. And I compare the amount of ammonium bicarbonate in that condensate with the titration method. I'm going to show you in the next slide how I compare again with different methods. So what we see here, interestingly, and makes sense, we see here that the most saturated aqueous solution in ammonium bicarbonate is that provided by the pasteurizer of the food waste digestate. Food waste digestate, we know it has a lot of ammonia, so it makes sense that CO2 and ammonia meet each other in the gas phase. And it also makes sense that the pasteurizer at 70 degrees enhance the mass transfer and the volatilization of these compounds afterwards. The other interesting part, if we look, we see that the manure digestate, the condensate from the manure digestate pipeline presents more ammonium bicarbonate than the condensate of the food waste digestate. So this means that the amount of ammoniacal nitrogen in the manure digestate is greater than in the food digestate. And by the way, I did the dilution of the samples of condensate because I got a oily phase in the sample. In the sample of the pasteurizer, I got an oily phase, and I did the titration in case these were the volatile fatty acids. Okay, so the titration, it has minimum buffer capacity. So I also estimate the content of ammonium bicarbonate by directly determining, not only with the titration methodology, but with the TOC, directly determining the content of total nitrogen and total carbon, which is inorganic, because which other form is going to be in the aqueous solution. And I empirically precipitate and extract this material using an anti-solvent method, okay? I'll cool down at 2 degrees the aqueous solution, and I add acetone, which is the anti-solvent. So here we can see that there is the direct relation, okay? The same trend we found. And the blue trend is the minimum amount of acetone that I need to add to promote this supersaturation, as I'm going to show you. Come on, this video has to work. So in this video, I am showing you how I promote the supersaturation. So I have 3 milliliters of the condensate at 2 degrees, and I start acetone in a small step. And you see that it starts to become whitish. You see? And I keep adding, and I take note of that. This is the minimum amount that I need to promote the supersaturation. And then I add until 40 milliliters to recover as much as possible, as I did with all samples. And the same results as before. The ammonium bicarbonate that was isolated, come on, man. The ammonium bicarbonate that was isolated has greater peaks than the commercial fertilizer. Only here the peaks were small, because when few ammonium bicarbonate is produced, only those crystals that present high stability prevail. If you produce a lot, it goes with there easily. So now that's all I have to say related to ammonium bicarbonate. I did not know that here you use it as fumigation. I know that in Europe we don't. It's not so far considered a fertilizer. Okay, and in the last conference I've been in Europe, we were discussing this point. So now let me tell you a little bit about a technology that I've been developing, which is the heterolactic fermentation of the Darius Larry. Okay, it's my business. I'm doing this not for a living, but so why? This is how heterolactic fermentation occurs, okay? This is a schematic of the lagoon that I will show you later. The lagoon that I was talking before. So here at the bottom, we have the manure, the solid manure, submerged, completely submerged in water under anaerobic conditions. And in that soaking process, the hydrolysis of the fibers take place. And that generates fermentable sugars. Here I have a molecule of glucose. And microbes are able to break that molecules of glucose in a molecule of lactic acid, ethanol, and carbon dioxide. This is heterolactic. If where homolactic would be two molecules of glucose, which by the way is nothing new. This is what is done for the preparation of silages with corn and grass for grasses. That is heterolactic fermentation. This graph I prepared for our rich event for telling young people that in the same way we provide our body with food in a good state to grow our muscles, we need to provide the soil with a material in a good state, fermented material, and not putrefying material, right? So, related to the homolactic fermentation, when you ask farmers whether they use something to promote this in silages, some of them they tell you, I am using propionic, butyric, formic acid as preservant. Other tells you, I am using lactic acid bacteria as inoculum. Others say, I am following my own criteria. This is what I find out. I am originally from the northwest of Spain. The gentleman is from here, from Cordoba. I am from the northwest of Spain, near Santiago de Compostela. I am from a village nearby. And I am moving around. I am going to Mazarico, Santa Comba. I am going to Trazo. I am going to a different county. I am going to Friol, a different county, Silleda. And I am collaborating, building business with farmers. I am telling them to ferment their manure. And what I'm going to show you is an example of how we do it. Why these people want to improve, they do the fermentation of their manure. So this is their lagoon. And this gentleman, by the way, this is a lagoon of 2 million liters. It's not a joke. And this gentleman wants to put this pile of cow bedding that we were just talking. This is a straw. This cow bedding is used for calves and dry cows. And if you want, I can explain you later what is the logistics in the farm, right? Because otherwise, if you use this hot bedding, this is hot bedding, they will have the mastitis, right? So this gentleman wants to put this pile in the lagoon. Why he wants to put this pile in the lagoon? For a number of reasons, but mainly because of the policymakers that they are telling farmers to build another facility of 10,000 euros or more to store this material. The farmer says, well, I prefer to pour it in the lagoon, which also helps the farmer afterwards in fertilization, because it does improve fertilization. But it's not always positive. Sometimes the fermentation of the heterolactic fermentation is inconvenient for them. And here we have to come just before, maybe that was the reason for the delay of my flight. Just before coming here, I have to go to this farm to add a controller for this fermentation, because the foam was reaching to the cow, to the feet of the cows. And this could have a problem. This could have a problem in producing irritation in the hooves of the cow, you see. Dermatitis is called, you see. So I have to go there, and I think I just received the payment, so I think it went good. So just to finalize my presentation, these are the top reasons I find now why farmers want to ferment their manure. First of all, they want an homogeneous fluid. We were discussing here he said here in the US, they want liquid fertilizer. Well, there is not that much difference. They want homogeneous fluid. Sometimes they cannot put the stirrer, or sometimes if they put it, they have to stir it a lot to take it out. So this is one. Other is that milk factories like Nestle, Lactalis, which is a friend company, currently they demand more and more this kind of technologies. Okay, they ask the farmer whether they apply these cocktails, all right. This might be because they want to decrease their carbon footprint. They care about the greenhouse gas. Farmers may care, but they care more about their pocket as well. It's true. And what do they care is about the smell, which Brett were telling us. Brett was telling us, and they tell me as well, I have to do something with this manure because neighbors are complaining, and I don't want to have problems with the neighbors. So you are going to tell me, and how this helps? Well, you got to think that this is anaerobic fermentation, but does not produce methane. We can discuss later if we feed this to anaerobic digestion, whether it increases the biogas production, and it does. In Ramiran conference that I went, they people advocating for this technology confirm that. And you talk to farmers, they say also greater crops. At the end of the day, is what farmers says, you know. And when we discuss about the price, they always tell me the same. If the product that you are bringing here does what you are telling us, then it's not expensive. No problem at all. Yeah, that's all. I am supported by Spanish government for the ammonium bicarbonate with the British government and also my own initiative. That's all in my presentation.